Thank you very much, and it's very nice to be able to come and talk to you again. I apologise in advance that some of these slides and some of what I'm about to say has had a bit of an outing. So if I'm repeating myself, I do apologise. I do try to introduce some new things because music is very much an ongoing theme of our work. And I'm one of the neurologists at the Dementia Research Centre just across the road, actually, those of you whose paths haven't crossed with mine. But, you know, it's a relatively easy gig to come and talk to people about music, and probably I suspect most of you. And a lot of people find it rather interesting to think about music and the brain, but it's a legitimate question, particularly if you're a funding body, to ask, you know, what use is this, really? And so some of what I do, not all of what I do, but some of what I do is really making the case for studying music in the first place, because you know, for most of us, music is a diverting recreation, and here it is sort of sitting in pole position in a major research program, you know, in a major centre of excellence. Very interested in using music as a tool to understand brain disease, and the argument runs that there are some aspects of particularly these brain diseases, frontotemporal dementia, which only music can really capture, or at least can capture in an easy way that we can test. And you know, music has many dimensions to it, of course, as most of you will realise. But I think the really important thing to keep in mind is that many of these dimensions are unique to music, so there is no other way to study them. So, you know, if you think about it, really music is the only really complicated code that we all use and understand, which isn't language. So, you know, if you're trying to sort of test theories about how the brain goes wrong when it doesn't process language properly, you know, one way to look at that is to contrast what goes wrong with what happens when the brain is asked to process music. And the reverse is also true. And, you know, on top of that, we know that patients with frontotemporal dementia, not just frontotemporal dementia, but for the purposes of today, our main focus and interest, have major problems processing music. And it's no accident that they have problems processing music, because they have problems with aspects of their daily lives that are much wider than music, but which are in some ways related to it. So, for example, we all know that music has strong emotional content most of the time. Patients with frontotemporal dementia have big problems processing emotions. And interesting to hear some of your comments. We used to say it was all about loss of emotions, but now we're sort of refining that to say, well, it isn't just that they can't express emotion or understand emotion. It might be that they express emotions, but that they do that inappropriately, or they don't get the register right. And that then leads into another big problem, which of course we've heard so much about already, which is that they have major problems understanding social signals, and music is one of the major social signals that we all experience, you know, a lot of the time, sometimes involuntarily. If you think about the ubiquity of music in the various places that we go to, which aren't actually concerts or times that we want to listen to music, it really is ubiquitous. So it's sort of bathing us all the time in this sort of auditory world that we inhabit. And, you know, in many ways, when we process musical signals, that's a little bit like that go into music. And when you think about, well, why should it be that music is a good probe of brain disease, and particularly frontotemporal dementia, it's not that mysterious when you think about the parts of the brain that do music. So my sort of favourite diagram of the musical brain is that one. This is a sort of very simplified outline of the brain viewed from the side. Those of you that have seen brain scans will look, I guess, somewhat familiar, really highlighting the lobes of the brain. And a lot of the brain is interested in music, and so the colours there are really coding the particular musical functions that those areas of the brain are doing, or they're processing. But more important than what the colours all represent, or what the particular areas are doing, at least in terms of the overall takeaway message, is that an awful lot of the brain is interested in music. And, you know, not just any old parts of the brain. You know, it's particularly these areas in the sort of the temporal lobe of the brain, the frontal lobes of the brain, which are the ones that really do music particularly. So, you know, it's not just sort of the processing of the auditory cortex, or the parts of the brain that just do hearing. It's all the other associated parts of the brain that surround those that are interested in memory and in regularities and in patterns and in emotions. So it's in some ways a very convenient way to probe those areas in a clinical or in a research setting. So I'm going to jump back. Now, poor old Ravel has had quite a lot of publicity for the worst possible reason recently, and he seems nowadays to be more in the news for the fact that he had frontotemporal dementia than for the fact that he... the front parts of the temporal lobe of that brain. And that is, again, by conjecture, by extrapolation, probably the sort of pattern that Ravel had, this really what we call focal atrophy of the brain, which is typical of frontotemporal dementia, and explains why it is that someone can have such selective problems, because in many ways, you know, he retained awareness of what was happening and he would remain competent in other areas of his life, but these particular aspects like the language and the voluntary action and so on were devastated. And the manuscripts there show just how striking the change was in particularly his written production. He went from being a very meticulous scorer, and Stravinsky called him the Swiss watchmaker because he was so meticulous in his calligraphy in sort of his earlier life, around 1900, and then under the throes of frontotemporal dementia, he was struggling to even write a letter, and you can see how untidy it's become and how degraded it's become thanks to the effects of the brain disease. And there is one other dimension to all of this, which is that people have found it irresistible to listen to Ravel's music like this and say, well, it's repetitive, it's rhythmic, it's monotonous, it's perseverative. This is clearly the music of someone with brain disease. Not just brain disease, but frontal dementia. You know, this is classic for frontal lobe damage. But I think the problem there is that that's in some ways wishful thinking, because it doesn't really fit with the facts of Ravel's own case. That doesn't stop people claiming that Bolero is in the sense a product of Pick's disease. And it doesn't really fit because, you know, for the reasons that we've heard before, as Freud said, sometimes a cigar is just a cigar. Ravel himself said, well, you know, I'm interested in this piece to create an exercising crescendo, and that's exactly what he did. And he went on to produce lots of other very, very different music after that. But it's often held up as an example, and certainly it's entered the popular consciousness that this is sort of what frontotemporal dementia does. It produces these very perseverative and monotonous rhythms. But it just goes to show you why, as in our clinical practice, we have to be careful not to jump to conclusions, I think. So, going back on track now. So, of course, we're a research centre, and we do really a number of different things, looking at how the brain understands and interprets patterns, but for the purposes of today, focusing on our work with musical patterns. I should say in advance, I'm not sure if there are any relatives of this lady present today, but if they are, I'd just like to say thank you so much for all the help that she's given us over the years. And this is an example of one study in which she participated. Now, this is a lady with a frontotemporal dementia syndrome, not behavioural variant, although many of the same behavioural changes are in fact a big problem in this aphasic variant, semantic dementia. For those of you that may not know or understand what semantic dementia is, it's a disease which affects really understanding of the world, and the way that usually presents is with a loss of understanding of words, of language. So it presents as an aphasia, and the reason that it does that is because the brain atrophy in this case is very selective. There, I hope, for the temporal lobe on the left side of the brain. So in neurologists and radiologists, when we project brain scans, we always put the right side on the left, keep things simple. This is the left side of the brain, which is the dominant hemisphere of the brain in most of us. And you can see, you don't have to be a neurologist or radiologist to see how shrunken that is by comparison even with the other temporal lobe, and certainly in comparison with the frontal lobes of the brain there. So this is an example of a very focal brain disease affecting a strategic area of the brain, which in this case controls language and semantic memory, as we say, our memory system that controls understanding of the world at large. And what does this look like at the bedside? It's a very short video of this lady trying to describe this scene, which is the scene that we on Queen Square carry around with us, our little green books for testing cognitive function. And one of the pages in that book is a picture which we use to elicit language from patients, and she's trying to describe what she sees in that picture.
Can you show me the spade in this picture?
The spade?
Do you know what the spade is?
Is it breathe out? I'm not sure.
That's correct. Yeah.
Oh.
What about the bucket?
The bucket.
Okay, no, that's the sand. That's
Ah.
a bit of the sand. That's the bucket over
Ah,
there.
sorry,
What,
yeah.
what about the oar? Can you see an oar?
Oar?
Do you know what an oar is?
No, I'm sorry.
Right.
No, I don't know.
Okay. What about, what's this in this one?
Oh, they're the things that we see all the time around us and that.
Right.
I can't remember the names of them.
Are they objects
And
or
daft I am.
animals?
Sorry?
Are they objects or animals?
They could be animals, aren't they?
Animals. Right.
Yeah.
What sort of animal do you think it is?
They're just the little ones, aren't they? I'm sorry.
Right. Do you know what colour they are?
They're white ones,
White ones.
red ones, aren't they?
Are they red ones, you think? Right.
Well, they look like them.
So she illustrates actually in that very brief video a lot of the features, and you can probably hear, even though superficially there's a lot about her speech which is rather normal. She's spending a lot of the time beating around the point, not really being able to find words, and then when she's put on the spot, really has trouble understanding words in her native language. And this is of course the big problem for patients with semantic dementia. But even beyond words, there's just a clue at the end there where she's starting to have to describe attributes of the gulls that she isn't really sure what colour they are. And this is an example of the sort of wider loss of knowledge that happens with semantic dementia. But the reason that I wanted to bring her case study along today is because one of the things that her family said really right throughout the course of the illness, through her contact with us, was that she was very, very avid for music, and she would, left her own devices, really listen to the CDs in her collection, the same CDs, sort of golden oldies, many, many hours a day. And she would, she'd sit in the car and listen to them, and would have to be sort of removed bodily, and she would spend large amounts of time sort of huddled next to the speakers at home, trying to listen to these things, and really deriving obviously a lot of pleasure from them. So that led us to wonder whether, in fact, one of the things that was happening was that despite the fact that she was losing a lot of understanding of things in the world at large, she was retaining some sense of the meaning of music. And so on the way through, I'll try and mention, particularly for those of you that have been through the Dementia Research Centre who know who all these people are, the people that actually led on this work. So this is really Julia Hailstone's work. And what Julia did was to design a way of looking at that, bringing that out in a way that we could prove that she had retained knowledge of music. And of course it's very hard to test knowledge by asking patients with an aphasia to identify a tune, what's that music, because they can't find their words properly. So you have to find some other way of demonstrating that they have retained knowledge of the tune. And the way that Julia used was to present her with the introductions to tunes that she knew, and then she would have to continue the tune. And really the only way to continue a tune like that, and someone gives you the first few bars of the introduction, is if you know the tune, if it's stored in your semantic memory, so that you can then do the same thing for sentences and for words as you do for melodies, for tunes, and see if there's a difference between them. And so this is an example of one of the trials. We tested her on a number of different trials, different tunes. This is an example of one of them. You'll hear Julia leading in with an introduction.
And you walk through the storm, throw your head up high, and don't dare to say, oh my life. Brilliant.
So what we've done actually, we notated all of those responses with the actual melody, and then with her response. We did that for each of the trials, each of the tunes, and analysed them. And what you can hear there is that even though she benefits a bit from having the tune going along with the words, or the words going along with the tune, she gets a few of the words. The words are really breaking down a long time before her knowledge of the pictures that compose the melody is breaking down. And in fact, if you do that in more extreme form and just present the lyrics alone without the tune, she was really a non-starter on that, and she couldn't really produce any of those continuations. And so what we demonstrated here was a relatively striking preservation of the knowledge of music, which was really, by that stage of her illness, about the only domain of knowledge that she did have preserved. And so she illustrated both this really striking preservation of music, independently of other branches of knowledge, but also this very, very avid liking for music, which we've since called musicophilia. And those of you that follow the popular press will know that term's has gained wider currency, thanks to Dr. Sachs. Musicophilia, this sort of craving or liking for music to an almost abnormal degree, is a feature of many of our patients, and it tends to be patients with somatic dementia, but it certainly isn't exclusive to them. We certainly have patients with behavioural variant who exhibit a very similar sort of thing. So more of that, come back to that later. But I first then wanted to go on to really the second major piece of original work I just wanted to mention today. Now, this comes back to this idea that it might be possible to use music to really model or represent particular sorts of social phenomena. And one of the things, if you think about music, we often talk about music as being, mournful, heroic. Might even talk about it as being playful or seductive, or people will, with very little provocation, build stories around music. And this is something that composers, of course, sometimes exploit. They write program music deliberately to bring this out. But even in purely instrumental music, normal people are remarkably good actually at composing narratives about what that's all about. The piano and the horn are having a dialogue, or they're having a conversation, or they're having an argument, and all this sort of stuff, which is actually not in the music. It's what we're grafting onto the music when we sort of almost treat the instruments as people. And so this led to the idea, well, what if we sort of looked at this deliberately to see whether, in fact, it's possible for to show that people with particular sorts of frontotemporal dementia lose that normal ability, that we would normally take for granted, of being able to attribute these mental states, particularly emotional states, to music. Because usually we're not talking about, with music, about shopping lists and memos, we're talking about emotions. And that seems to be very much, if there is such a thing as the language of music, what that's all about. And so the jargon that psychologists use to describe this sort of process is theory of mind. And so the idea is that we, all of us, automatically, we don't think about it, we take it for granted, are continually theorising about the contents of other people's brains and feelings. And we're interpreting what it is that they're feeling. And sometimes, even when they're trying to disguise what they're feeling, we're actually rather good at picking up what message is really being conveyed. And this is also sometimes called mentalising. And I've given, because actually, apart from music, another very useful way of kind of illustrating what I mean by that is to show you cartoons. And this is sort of an example of what I mean. So usually when I show this slide, people call out, read the captions. So this time I'm going to read out the captions to save that from happening. So the cartoon there on the left, so this is an example of a kind of a belief that's in someone's head that we suddenly understand when we get the joke. So what she's saying is, that's Marcus in his prime, proud, arrogant, top of the heap, yet tenderness itself with his loved ones. I forget who the man is. So what you've got there is a fairly radical perspective change, and you suddenly realise that her belief and her message about that picture is not, shall we say, the standard one. The other cartoon is in some ways more related to music and perhaps even more interesting, and that's a change of someone's emotional state, or at least a very imminent change in someone's emotional state. So we've got the rather smug father there saying to the rather frightened looking little boy, well, I give up, Robert. What does have two horns, one eye and creeps? And we can see from the rest of the cartoon that he's about to have a radical change in his perspective in the next few minutes. So, that's an example of a kind of an emotional mental state that's being coded or changed, a shift in emotional mental state. So what we did was to put this into a musical guise. So this is work that was led by Laura Downey, who created these stimuli. So we basically wanted to see whether it was possible for patients with frontotemporal dementia to attribute mental states to music as well as normal people. And the prediction, of course, was that they would have a problem with this, because one thing that patients with frontotemporal dementia, particularly the behavioural variant, are terrible at, as most of you will know, is understanding what other people are feeling. And so we were kind of here really interested in using music as a shorthand, a really controlled shorthand for those much sort of broader repertoire of social routines that would happen in real life. But of course, this is a rather unusual task to set someone. I mean, you don't normally get put on the spot. You may make up stories to yourself about what music is saying or meaning, but you don't normally have to say to a psychologist in a multiple choice format what it is that music is expressing. And so what we needed was a carefully controlled task. And so what Laura did was to create stimuli that were still examples of music representing things, but instead of representing emotional states, they were representing things. So that would be, for example, the sound of a train or the sound of a thunderstorm. So I've got some examples of the sorts of things that we played, and again, we presented people with a number of different trials in each of those two conditions, if you like. So this would be an example of the sorts of stimulus that they heard in the condition of trying to decide mental state. This is an example of the music. So most of our healthy older controls agreed that that was most likely to be mysterious when presented with a choice of is it playful, mysterious, or pleading. Okay, but for the non-mental conditions, I've got an example of those. This was one such example. Etc. So that's an example of a train. So presented with the choices of train, sunrise, or storm. Most of the, in general, there was a consensus in the healthy older people that that was a train. And the other thing to say is that, so we obviously needed to have control data, so it wasn't just us saying what this music represented. We needed to show that there was agreement in people who weren't primed to what we thought we were putting into the music. And of course, the other thing is that because there is music around, which is well known to represent trains and storms and things, we went out of our way to choose music where the original music was not designed to represent that thing. So that, for example, that particular example is the foxtrot from the Chairman Dancers. It's got nothing to do with trains. So this was an example of presenting people with music that wasn't really familiar to them, where they had to make a decision that wasn't based on the fact that they'd heard that music, you know, linked to a public event or something of that kind before. And so what we showed, I won't bore you with all the detailed statistical analyses, but what we showed was that patients with frontotemporal dementia, compared to healthy controls, did have a problem with understanding mental states, but did not have a problem with the attribution of these other non-mental things. So despite the fact that it is an extremely odd thing to ask someone to sort of decide whether that's a train or a thunderstorm, they still managed to do that to a level that was comparable to controls, whereas they did in fact fall down on the attribution of the mental states. And we showed an anatomical correlate of this. So what we did was to take, what we can do as a very useful technique in general, is to take patients' brain scans and then measure what regions of the brain correlate with performance on the tasks that we've administered to them. And that's called voxel-based morphometry. And we did that in this particular instance. But actually what I wanted to show you is an example of getting in another one of our studies by sort of a slide. By some sleight of hand, is actually not Laura's anatomical results, but the results of Rahani Omar, who did a PhD with me going back a couple of years, who did a study of somewhat similar, but was asking a rather different question about emotion recognition, but found very similar conversion anatomical results. So I thought this one would do double duty. And this was really showing areas of the brain where, in particular, grey matter in the brain regions, correlates with performance on recognition of that dimension of music, be it emotions, emotion, or theory of mind, mental states, etc. And what it shows is something that looks a little bit like a disease map of frontotemporal dementia. So we've got, those of you that have seen brain scans before, this is at the front of the brain. We've got these areas, particularly in the sort of deep areas of the frontal grey matter, going out to these areas at the bottom of the frontal lobes. And these are all areas that are concerned with the control of behaviour, but also understanding of others' emotions, understanding of others' mental states, programming reward, so what it is that we find pleasant, what we might seek out to do again, and these are all areas that correlate with the ability to make those inferences about music. And so what I think this work illustrates, and this is really part of a noble tradition of work, not just in patients with dementia, but more widely, is just how surprising it is to think that something like music could really be tapping into these areas of the brain, because these are some very, very primitive areas of the brain. They're areas that are concerned in monkeys with survival, with reproduction. They're not areas that are concerned with processing art forms. They evolved to do something else far more serious, and yet music seems to be able to access these things. And so I thought, with a view to this talk coming up, I was asking my 7-year-old on the weekend if he could give me some examples of things that we all do, or people all do, but no monkeys can do. And I can promise you, for those of you that are wondering, that you can't be the offspring of 2 neurologists and not have a strange upbringing. So Felix is a victim of that. But we thought about this for a while, and actually, we're saying things like, well, we all write. And I said, well, no, we don't all write. There are lots of people on the earth who don't write. Well, we all make tools, and well, that's true. We all do make tools, but then so do some monkeys. And if you think about it, we gradually whittled this down. We agreed that we talk. We all talk, no monkeys talk, and we all do music. And this is true of all known human societies. So when the Foray Highlanders were first discovered by white people in the 1950s, they had music. It's nothing like the music that we have, but it was their own complex musical culture. And not all human societies have medicine, and not all human societies have maths, and certainly not all human societies have any one of these other activities that we might nominate, but they all, as far as we know, have music. And so the question is, why on earth should this be? I mean, what is it about music that means that we all seem to home to it as a species? And what is it that seems to be defining us as a species? As far as we know, there are no other species that produce music. And so, this leads to the sort of, I suppose, the more speculative proposition that one of the things, apart from helping us understand frontotemporal dementia, one of the things that frontotemporal dementia can put back is a kind of a clue as to why music might be important to us. And I would suggest that one of those possible causes or reasons is that music helps us to learn in a controlled way the sorts of mental states and emotional reactions that we need to deal with other people. And obviously no one is suggesting that our ancestors, living in caves, had concerts the way that we understand them, but they would certainly have had something like singing. And as some of you may know, so do monkeys. Gibbons have very complicated songs, for example. They don't use them the same way that we use music, but the raw materials are there. And so the idea runs that these raw materials might have been linked up with this human capacity for understanding social signals, and it might have been music or something like it that was helping to drive that along. And so we've since gone into print saying this, that one of the things that frontotemporal dementia helps us to understand is what the biological purpose of music may have been in the first place, because frontotemporal dementia is such a unique disorder of human social cognition, of understanding the feeling states of other people. And so, sort of bring things to a close. So, what conclusions can we draw? Well, that was a very speculative one, but one thing I think we can say, staying close to the data, to our results, our research results, is that music is a way of measuring skills and capacities that patients with frontotemporal dementia retain, even when they have profound brain damage. Now, I'm not suggesting that all patients with frontotemporal dementia will be competent musicians or retain an interest in music, but the fact that it happens at all is the really important message to take away. And it's not just any old information that it's telling us. It's telling us some very specific things about what the nature of the brain malfunction is in frontotemporal dementia, and the various specific clues to what kinds of social signals patients with frontotemporal dementia have problems with. And not only that they have the problem, but what areas of the brain are responsible for that malfunction. And so what that then leads to in turn is that music, as per the promise of my introduction, can be used as a tool to help us understand this brain disease. It's not quite at the level of routine diagnosis, but as we've heard, so many illustrations of just how difficult it is sometimes to pin down the diagnosis at a stage where it's early enough to be useful. It's still so easy to confuse frontotemporal dementia with other things, that we really do need to be open to these novel, completely off the wall, in some cases, like music. approaches to sort of early things that we might be able to measure that actually give us a chance to be able to pin something down, to say, well, that's a problem that this person has that they should not have. Normal people of this age group do not have, in a way where it's often so difficult to try and decide, do they just have a personality disorder or are they just depressed? And of course, the wider promise is that beyond understanding, we'll be able to use this knowledge to treat and to help people in hopefully a practical way. And I think we're already seeing some of that, because it's certainly right now, today, possible to use music therapy and music as a way of helping to manage complex, difficult, challenging behaviours. We're some way from being able to use music as a kind of a specific therapeutic tool, but I think the kind of brave new world possibility is that if we had disease-modifying drugs, I can absolutely see with all those brain areas that we see coming online which are processing music, that one could envisage a situation where someone was on a drug treatment and then they were also having some form of musical rehabilitation to help reprogram those networks. Those of you that were really maybe thinking come off it, that really does sound like science fiction. Outside the realm of frontotemporal dementia, where we actually have a genuinely reversible illness, and I'm talking here about forms of temporal lobe epilepsy, where we can actually give someone a drug and see what happens when you remove the effects of the disease. What sometimes happens in those patients is that they become intensely musicophilic, and it's a very specific and unusual behaviour pattern that leads them to become very avid for music, but not for other kinds of rewarding stimuli. And so what that says to me as a neurologist is that brain network that went wrong with their epilepsy has been profoundly reorganised. And we tend to think of music relatively as a benign, more or less as a benign phenomenon. But you can imagine how that could be taken as a starting point, a jumping off point for being able to do that in a controlled way, to really assist the reprogramming of those brain networks if we only had a drug that was effective in stopping the march of the disease. So if you really pushed me, I would say that might be where some of this work is going. And I wanted to, they say you should never ever have slides after your conclusion slide, but I wanted to leave you with a slightly positive, hopefully you think it's positive, news or just indicate to many of you sitting in this room, just what you've made possible in terms of research. So this is just our music research, it's only a selection of the papers. But these are some of the things, and several of these were the basis for people's PhDs or MDs that led them to go on to successful careers doing other things, which have been based around really the willingness of patients and families to help us with our research. And there are some of the papers describing this and some of the other things to do with our music research that I didn't have time to go into today. So I want to leave you with thanks, and the thanks obviously has to go to the whole team and of course our supporters and our major funders, but absolutely above all to you. So I wanted to say thanks at that point.